So usually when we talk about our digital lives, in our physical lives, we kind of treat them like they operate in completely separate, quarantined universes, you know?
Oh, absolutely. Like there's a huge divide there.
Right, because on one side you have the computer, it's hyper-organized, it's neatly categorized, and everything basically runs on strict deterministic logic.
Exactly. If you input a specific command, you get a specific output. No surprises.
Yeah, exactly. But then on the other side, you have the physical world. You have nature.
Yeah.
And nature is just, I mean, it's unpredictability.
It's fluctuating weather, invasive pests.
Total unapologetic chaos.
Yeah, exactly.
And the general assumption is that these two environments demand entirely different mindsets. Like, you don't win a spreadsheet to a mud fight, right?
No, you really don't. We enforce a very strict mental boundary there.
Yeah.
The keyboard is it's an environment built for total control and precision, while the soil is an environment where you are forced to get your hands dirty, you know? You have to surrender to the elements and essentially accept that you are not the one in charge.
But today we're taking a deep dive into an archive that completely blurs that boundary. We're going to look at what actually happens when someone applies the strict, serialized logic of a server room to the absolute chaos of a backyard garden.
It's a fascinating crossover.
It really is. So we are pulling from a blog post dated April 2026 from a site called cayennensis.org. And the post is titled Notes on Gardening, Part 867.
Right. And the author of this site is a gentleman named Ang, and he has a very specific way of identifying himself, which I love.
Yeah, the old software plumber.
Yes.
Right.
He refers to himself as an old software plumber. He spends his nights tinkering with free Libre and open source software.
Right, the flawless community.
Exactly. A culture that is just entirely dedicated to transparent, accessible, and community-driven code.
But we are stepping away from his keyboard today. We're looking at a deeply specific update about how a programmer, navigates the dirt.
It's a very different interface.
Totally. We're going to explore how scattering seeds functions as a biological algorithm and why identifying a sprout requires surviving an intentional information deficit.
That's a great way to put it.
And we'll also see how a wild plant with tiny blue flowers teaches a master class.
Yeah.
The difference between back-end utility and front-end user experience.
There are so many layers to this single post.
Oh, for sure. But to even grasp the sheer gravity of a post called Part 867, we have to zoom out first. We have to look at the architecture of this author's mind, because the scope of his documentation is, it's difficult to wrap your head around.
It really is. When you pull up the archives of this site, it becomes immediately clear that this is not a casual, sporadic diary.
Right, it's not someone just posting a picture of a tomato once a summer.
No. It is a highly structured relational database of a human life. This site has been running continuously without a break from 2011 to 2026.
I was scrolling through the archive sidebar, and the sheer volume of output completely changes the context of the gardening post for me.
Yeah, the numbers are wild.
They really are. Back in 2011, he started relatively quietly with 26 posts. But if you look at the block of years from 2022 through 2025, the output locks into this staggering rhythm.
It's incredible discipline.
He published exactly 730 posts a year for 4 consecutive years.
Wow.
That is exactly 2 posts a day, every single day, 0 exceptions. And it's the categorization that really gets you,
Right, because it's not just a stream of consciousness.
Exactly. He has Notes on Gardening, Part 867. But running parallel to that, in the very same month, he's publishing Notes on Haskell Programming, Part 109.
And Notes on Fish Keeping, Part 233.
Yes. Plus, there are these entirely isolated, heavily serialized projects dedicated to his dieting, his daily exercise routines, his photography.
Synthesizing that much raw data across such wildly diverse fields, it reveals a fundamental belief system.
How do you mean?
Well, for this author, there is no conceptual dividing line between professional technical labor and a relaxing weekend hobby. Everything is a system.
Oh, yeah.
And if something is a system, it generates data, right? Which means it is worth documenting. He is applying the exact same analytical rigor to the water parameters of his aquarium as he is to functional programming in Haskell.
That is so interesting.
He's observing the variables, logging the inputs, and iterating on the results. Constantly.
It's like he has turned his physical existence into a massive public version control system, like a GitHub repo for his life.
Yes, that's exactly what it is.
He's constantly pushing commits and updates, not just to his software projects, but to his body weight, his guitar practice, and his potted plants.
Right.
But looking at the sheer discipline of maintaining 2 detailed logs a day for years.
Mm-hmm.
I have to challenge the actual lived experience of this.
Okay, let's hear it.
Doesn't serializing your life to this extreme degree defeat the entire purpose of having a hobby?
That's a fair question.
I mean, if I have to label a casual afternoon of watering my plants as Part 867, it stops feeling like an escape from my desk job. It starts feeling like I just assigned myself an administrative chore.
Yeah, that is the natural assumption for anyone who uses hobbies to escape structure, you know? But for an old software plumber, structure isn't the burden. Ambiguity is the burden.
Wait, really? Ambiguity is the burden.
Think about it. In software development, there is a concept known as technical debt.
Okay, right.
If you write a piece of code to fix a problem today, but you don't document how it works or why you wrote it, you're essentially taking out a loan against your future time.
Oh, I hate when that happens. You go back a month later and have no idea what you did.
Exactly. Eventually, that undocumented code will break, and you will have to spend hours reverse engineering your own thought process just to fix it. Keeping all those unrecorded variables in your head is what actually causes stress.
So the documentation isn't a chore for him. It's like a pressure release valve.
Precisely. By externalizing every single observation into these numbered, searchable logs, he is completely offloading the cognitive burden.
He doesn't have to remember it all.
Right, he doesn't have to rely on his memory to recall the exact nitrogen levels of the fish tank from 3 weeks ago, or what specific bug he encountered in Haskell last Tuesday. It is safely archived in the system.
Wow.
The extreme categorization is the very mechanism that allows his brain to relax. He is projecting the comforting, reliable order of the digital world onto the unpredictable, messy physical world.
Okay, that reframes the entire blog for me.
Yeah.
The archive is literally his external hard drive.
Exactly.
But this leads to a massive pivot in the source material. It genuinely threw me off.
The planting method.
Yes. You read Notes on Gardening, Part 867, and based on everything we just discussed about his hyper-categorized mind, you brace yourself for a spreadsheet.
Right. You expect a highly deterministic ledger detailing exactly which seed was planted in which quadrant of which pot.
Cross-referenced with the exact soil pH and ambient humidity.
Yeah, you would expect a guy with 104 sequential logs dedicated to Elixir and Erlang programming to treat a planter box like a meticulously mapped memory grid.
But he throws that entire playbook out the window. When it comes to the actual physical act of planting, Ang admits in the post that he has completely stopped tracking his seed germination projects in detail.
It's a complete 180.
It's a masterclass in chaos.
Mm-hmm.
His current method is he basically takes whatever random leftover seeds he has lying around, finds any empty spot in his various potted plants, and just blindly scatters them into the dirt.
Just tosses them in.
He just tosses them in. And he openly admits that because of this entirely randomized approach, he has created a massive downstream problem for himself.
Of course he has.
When the seeds actually sprout, it's incredibly difficult for him to identify what plant is actually growing until it matures past the seedling stage.
Right. It feels like a paradox, but he has actually recognized the fundamental difference between a deterministic system and a probabilistic one.
Okay, break that down for me.
So in software, if you input a command, the compiler executes it immediately and gives you a clear output. You can trace every single variable from start to finish.
Right. Cause and effect is instantaneous.
Exactly. But biology operates with an unavoidable built-in latency. A seed is effectively a heavily compressed, self-extracting archive.
I love that analogy.
You bury it in the dirt, but you do not get to see the interface right away. By scattering the seeds randomly, Ang has basically surrendered to the biological process. He has learned to accept a prolonged period of what we could call an information deficit.
But it's an information deficit that he intentionally engineered. I'm still hung up on how the guy who logs 109 parts on Haskell programming just accepts total ambiguity in his planter boxes.
It does seem contradictory.
I mean, he's basically throwing random snippets of executable code into a black box compiler, walking away, and just waiting to see what manages to run. How does a systems thinker justify that kind of blind spot?
By recognizing that the chaos is actually a highly efficient optimization strategy.
Wait, really? How's that efficient?
Consider the physical constraints of his environment. He's working with potted plants, meaning his square footage is strictly limited.
Right, he doesn't have an acre of farmland.
Exactly. However, those pots have empty gaps of soil between the established plants. In computer science, unused memory or idle server space is a wasted resource.
Oh, wow. I see where you're going with this.
By constantly scattering whatever seeds he possesses into those unused gaps, He is maximizing his available compute cycles.
That is brilliant.
He is outsourcing the actual calculation of what can survive to the environment itself. The soil, the available light, the water, they will determine which seeds germinate and which fail.
So he's letting the environment run the filter. He doesn't need to document the failures or map out the perfect conditions because the soil literally does the math for him.
Exactly. If a seed doesn't sprout, it simply gets reabsorbed by the system. He only needs to dedicate his attention to the successes.
Man, that is a wildly different way to look at gardening. But that brings us back to his problem of the information deficit. When those successes first breach the surface, they all look nearly identical, right?
They do. Aang notes that he has to wait for the true leaves to appear before he can catalog what the soil has produced.
The true leaves. Okay, let's talk about that.
Right, so in biology, the very first leaves that emerge from a seed are called cotyledons.
Cotyledons, okay.
They are essentially generic solar panels. They're powered by the energy stored inside the seed casing itself. They don't reflect the specific genetics of the mature plant.
So they just look like generic green sprout.
Exactly. It's only when the root system taps into the soil and the plant begins executing its actual genetic code that the second set of leaves, the true leaves, unfurl.
Ah, so that's the moment the plant declares its specific class and function.
Precisely.
Which means navigating this wait-and-see algorithm requires relying on biological markers that really stand out against the noise of a crowded, chaotic pot.
You need a clear signal.
Right. You need a sprout that throws a very specific visual flag when it hits that true leaf stage. And that is where the star of part 867 comes into play. The blue porterweed, or, as he logs it by its scientific name, Stachytarpheta cayennensis.
Quite a mouthful. But in a planter box crowded with mystery sprouts all competing for resources, the blue porterweed has an unmistakable visual signature.
Oh, yeah. Aang notes that the true leaves of this plant have a very specific morphology. They feature a deeply rugose texture, meaning the surface is heavily corrugated or wrinkled.
Right, very textured.
Along with edges that are coarsely serrated, kind of like a bread knife.
Spotting those wrinkled, toothed leaves emerging from a dense cluster of generic green sprouts, it's the equivalent of scanning a massive, chaotic log file and suddenly finding the one unique error code that tells you exactly what process is running.
Yes. You see the serration, the latency period ends, and the information deficit is resolved.
Boom. You know what you have.
But, the visual signature isn't even the most fascinating part of this specific plant. It's the origin story of how the blue porterweed got into Aang's ecosystem in the first place.
This part is so cool.
Right. He specifically mentions that he didn't buy it at a store. He originally harvested this species from the wild, quote, quite some moons ago. He brought it into his own pots, cultivated it, and successfully extracted the seeds to start his own self-sustaining loop.
This is where his identity as an old software plumber deeply intersects with his gardening. On his blog, Aang explicitly lists his support for organizations like the Electronic Frontier Foundation and the Free Software Foundation.
Right, the open source advocates.
Exactly. The core ethos of these groups is that tools, knowledge, and code should not be locked behind proprietary corporate walls. They advocate for systems where the user has the freedom to study the source code, modify it, and distribute it independently.
Okay, so how does that translate to the plants?
When Aang harvests a wild plant, cultivates it, and learns how to extract its seeds, he is applying that exact open source philosophy to biology.
He's actively avoiding vendor lock-in. I mean, if you go to a commercial garden center and buy a packet of patented hybrid seeds, you're essentially licensing proprietary software.
That's a perfect way to look at it.
Those plants might grow beautifully for one season, but many hybrids are intentionally bred to produce sterile seeds. The manufacturer literally forces a dependency. You have to go back and buy a new license, a new packet of seeds, every single spring.
Exactly. By seeking out a hardy, wild species like the blue porterweed, he has bypassed the commercial supply chain entirely. He found an open-source biological repository out in the world.
He forked the repo?
He effectively forked the repository. He took a cutting or a seed, brought it back to his local environment, and figured out how to compile it. By extracting the seeds himself year after year, he now maintains complete local biological autonomy over this species.
He's hosting his own instance of the plant.
Exactly.
And from a purely functional standpoint, this biological software runs flawlessly. Aang documents that once this plant is established, it is a localized powerhouse.
It really is resilient.
Yeah, as long as the root system has adequate space to excald, the blue porterweed thrives completely on its own in full punishing sunlight. He notes that it requires zero fertilizer and almost zero maintenance. It powers itself up to the height of a full shrub entirely under its own biological steam.
If you are evaluating the plant purely on its back-end utility, it is a triumph of independent architecture.
It's bulletproof.
It's the biological equivalent of a lightweight, incredibly robust server application that never crashes, never drains your system resources, and requires zero administrative oversight. It just quietly does its job in the background.
And this is a massive but Ang is forced to admit that this bulletproof utility comes with a significant design flaw.
Yes, the aesthetic problem.
Aesthetically, the plant is a failure. He observes that the flower clusters produced by the blue porterweed are incredibly small and sparse. Because the visual output is so minimal, if you grow a single solitary stalk of this plant in a pot, it looks, in his own words, quite dull.
This specific observation cuts to the core of a tension that exists in both natural ecosystems and software engineering. It's the divide between utility and design.
The back end versus the front end.
Exactly. You can engineer a back-end system that is structurally flawless. It can be independent, robust, and require zero maintenance, perfectly mirroring the survival traits of the blue porterweed.
Right.
But if the front-end user interface, the part that people actually interact with and look at, is unengaging, the end user will struggle to see the value. The plant succeeds at surviving, but it fails at being beautiful.
So it's a completely paradoxical organism. It's a rugged, low-maintenance plant that actually demands a highly strategic, high-maintenance deployment to justify its space in the garden.
You can't just plant one and walk away.
Right. Or you just end up with a dull, wiry stalk taking up a pot. Ang notes that to overcome this aesthetic limitation, you have to engineer density. You have to grow a large cluster of them together, so the sheer volume of the plants creates a lush, dense foliage.
It forces us to recognize that context dictates value.
Context dictates value. I like that.
Yeah, I mean, a single tiny blue flower on a wiry stalk registers as a disappointment, but a massive shrub composed of hundreds of those tiny flowers, layered over dense corrugated leaves, creates a lush cluster that completely transforms the visual landscape of the garden.
It becomes a feature, not a bug.
Exactly. Independence and rugged survival are excellent baseline traits, but they're rarely enough on their own. The way individual elements are grouped, deployed, and contextualized completely changes their ultimate impact.
Which is an incredibly profound design principle to pull from a scattered handful of wild seeds.
It really is.
And it perfectly encapsulates the journey we've taken through this archive today. I mean, we started by trying to comprehend the staggering discipline of an old software plumber who spent 15 years serializing his daily life into an unbroken, searchable database to ward off the cognitive debt of ambiguity.
And from there, we explored how that same hyperstructured mind learns to embrace the chaotic wait-and-see algorithm of the soil, right? Utilizing empty dirt as free compute cycles and allowing the environment to filter out the failures.
We saw how that chaos demands strong visual markers, leading to the rugged, serrated leaves of the wild-harvested blue porterweed, which was a masterclass in bypassing proprietary supply chains to establish open-source biological autonomy.
A truly open-source garden.
Yeah. And finally, we unpack the tension between a bulletproof back end and a dull front end, learning that even the most self-sustaining independent systems often require the density of a cluster to actually produce something beautiful.
It just reinforces the reality that looking at the world through a single lens is always limiting, you know? The strict logic of the server room provides an incredible framework for understanding the latency and optimization of a planter box.
Just as the messy reality of the soil provides immediate, tangible lessons about user experience and design.
Exactly. I really appreciate you taking the time to explore this intersection of code, open source philosophy, and organic growth with us.
And as we close the book on this deep dive, I want to leave you with one final thought to explore on your own. Ang has reached part 867 of his gardening notes, sitting alongside hundreds of other logs, meticulously tracking everything from his daily exercises to his fish tanks.
It's an amazing achievement.
It is. So think about a casual, undocumented hobby you enjoy right now just for the sake of it. If you were to sit down today and officially log a part 1 for that activity, and you committed to updating that ledger every single day until you reach part 867, how fundamentally would the way your brain processes that simple joy change?